Here we have a SAT math problem. Okay, let's go over the question. 10b positive 6a times x square, positive 9a square, negative 25b square times x, negative 12 times ab equals to 0. The equation above has two real solutions where a and b are constants. The sum of the solutions to the given equation is k times 21a negative 35b, where k is a constant. What is the value of k? Okay, the question says a, b and k are constants. Then we have to consider the x as a variable. Then it is a quadratic equation in standard form. That is ax square positive bx positive c equals to 0. We consider this one as a standard form of a quadratic equation. Usually when we solve a quadratic equation, we will be getting two solutions. That is two values for the variable x. And there is a formula to get a sum of the two solutions. That is a negative b over a. We take negative sign, and here this b is the coefficient of x and it is divided by a. A is the coefficient of x square. Okay, now let's consider the information we have over here. There is a sum of the solutions to the given equation is k times 21a negative 35b. That is a sum of the two solutions equals to k times 21a negative 35b. Okay, for this sum, we can find the stuff using the formula we have over here. That is, first we have to write the negative sign, then we have to take the coefficient of x. In our quadratic equation, the coefficient of x is 9a square negative 25b square, and a is the coefficient of x square. The coefficient of x square over here is 10b positive 6a equals to k times 21a negative 35b. Okay, here we can factor this expression. Okay, now let me do that separately. Let me take this expression 9a square negative 25b square, and we can write this 9 as 3 square, and also here we have a square negative. We can write this 25 as 5 square, and we can take this b square as it is. We can write this 3 square times a square as 3a the whole square negative, and we can write this one as 5b the whole square. Now, let me consider an algebraic identity, that is the difference of two squares, a square negative b square. We can write the difference of two squares over here in factor form, that is a positive b times a negative b. Okay, when I consider this expression, it's exactly in this form, a square negative b square. At the place of a, we have 3a. At the place of b, we have 5b. So to get the factor form for this one, we have to use the product of two binomials over here. At the place of a, we have to write this 3a, that is 3a positive. For b, we have to write 5b. So the same we have to for this one as well, that is 3a negative 5b. Okay, here I got the factor form of this expression. Now let me plug in this factor form for 9a square negative 25b square over here. Then I'm getting negative 3a positive 5b times 3a negative 5b. Okay, divided by, when I consider the terms of the expression in denominator, both the terms have the greatest common divisor 2. So we can factor 2 out. When 2 is factored out, to get the stuff inside the parenthesis, we have to divide the terms by the one I factor out. When I divide this 10b by this 2, I am getting 5b positive. When I divide this 6a by 2, I am getting 3a equals to k times. Here, when I consider the stuff inside the parenthesis, both the terms 21a and 35b have the greatest common divisor 7. So we can factor 7 out. When 7 is factored out, to get the stuff inside the parenthesis, let's divide both the terms by the one I factor, that is 7. When I divide this 21a by 7, I am getting 3a negative. When I divide this 35b by 7, I am getting 5b. Okay, here we find 3a positive 5b, here we find 5b positive 3a. Actually 5b positive 3a and 3a positive 5b, both of them are same. So we can cancel this one and this one. Then the resulting equation is a negative of 3a negative 5b divided by 2 equals to k times 7 can be written as 7k times 3a negative 5b. Okay, now let me erase this stuff and continue the problem. Let me take this equation as it is. That is negative of 3a negative 5b over 2 equals to 7k times 3a negative 5b. Okay, according to the question, we have to find the value of k. To get the value of k, we have to get rid of this 7 and also this 3a negative 5b. For that, let me multiply both sides of this equation by 1 over 7 times 3a negative 5b. Let me do the same thing on the left side as well. That is times 1 over 7 times 3a negative 5b. Okay, here this 7 will cancel out. This 3a negative 5b, 3a negative 5b will cancel out. Here 3a negative 5b, 3a negative 5b will cancel. That is here 1 times, here 1 times. Okay, here we have negative 1 in numerator. 1 times negative 1 is negative 1. And here we have 7 times 1 is 7. 7 times 2 is 14. On the right side, we just have k. That is k times 1. Okay, here I got the value of k. It is negative 1 over 14.